Hi, Mr. Foley here. I'm going to talk a little bit about radians, which is sort of surprisingly maybe a brand new way to measure angles. So you're obviously familiar with measuring angles in degrees, and today we're going to learn a whole new way to do it. And hopefully you've sort of discovered a little bit about this new way in the group activity that you recently completed using this GeoGebra sketch. And so we might say, well, why do we need this new method of measuring angles? And it's basically because the idea of degrees is not really very mathematical. So there are 360 degrees in a circle, we know. But there's no mathematical reason for that. Some people think that it's maybe because the length of a year, the time it takes the Earth to go around the sun, is about 365 days. 360 is sort of a nicer number than 365 because it's more evenly divisible by a wider variety of numbers. But there's definitely no mathematical reason why that should be the case. And so it's going to turn out that this radian measurement that we're going to talk about today is much more mathematical. And it turns out that in calculus, we pretty much just use radians when we're measuring angles. If you try to work with degrees, it just makes life, you can do it, but it makes life so much more complicated and messy when you're doing calculus. And so we're going to definitely work on getting familiar with radians here in the next few weeks. And so how does a radian work? Well, it's sort of what you were working with in that GeoGebra sketch. A radian is an angle that cuts out an arc that's equal to the length of the radius of the circle. And so we put the vertex of the angle on the center of the circle. We've got the radius of the circle, and then we cut out an arc that's equal to that radius length. And the first thing you have to worry about, which is what you guys were working on in the activity, is, well, couldn't that angle change if the size of the circle changes? And what you should have discovered is that no, that is not the case. If I get that arc equal to the radius length, the radius here is 3, I've got 57.41. When I change the radius to 2 and keep the arc length equal to that radius, it's still 57.41. It's sort of just like a similar triangle type thing, if you remember that sort of idea from geometry. When I make the circle bigger, still works, right? So it turns out that 1 radian is about 57.41 degrees, sort of this random number, but that's the way it works. And you can then continue doing this with more radii. And so if you go 2 radii around the arc around the circle, you've now got an angle that is 2 radians, and you can see it's over here. Looks like, a little more than 90. 3 radians, almost halfway around the circle. And so now what we need to think about is, okay, what's the relationship between the old and the new? What's the relationship between degrees and radians? And to do that, we need to make use of the circumference formula for a circle. So think back to your geometry or middle school days or whenever. Can you remember the formula for the circumference of a circle? Let's see if you can pick the right one here. All right, so the formula for the circumference of a circle is 2 pi r. And so that means the radius multiplied by 2 pi gets you all the way around the circle. And so if you get rid of that 2, you're only going to go halfway around the circle. And so the cool thing is, notice that means halfway around the circle is pi times the radius. But the radius is what gives me that 1 radian. And so here turns out to be the key factor. The key factor is that 180 degrees is equal to pi radians. And for those of you who love dimensional analysis in chemistry or some other science class, this is basically going to turn into a dimensional analysis problem where that's our unit of conversion. 180 degrees equals pi radians. And so it's like, 1 kilometer equals 1,000 meters being a conversion factor. And so now we can convert back and forth in 2 directions. And so if I've got 135 degrees and I want to convert to radians, 135 degrees, I want to get rid of degrees. So I put degrees in the denominator, and then pi goes on the top. That's my conversion factor. And then I can just multiply it out, and then it's usually nice to reduce. So 45 goes into both of those, and so it reduces to 3 pi over 4. And it's definitely nice to keep that pi in there. That's the exact answer then. You could type it out on your calculator and get a decimal approximation as well. You can also convert in the other direction, and so if I want to start with 5 pi over 6 radians, and convert to degrees, now I flip it over, that conversion factor. The pi's cancel. The 6 goes into 180 30 times, and I get 5 times 30, which is 150 degrees. And so 2 different ways of measuring the same angle. All right, so why don't you try a quick one on your own, see if you can convert 70 degrees to radians. So 70 degrees to radians. Give it a shot. All right, see how that went. And so remember, it's just a conversion factor. And so the thing we want to get rid of goes on the bottom, in this case degrees, and 180 degrees is equal to pi radians. And so we get 70 pi over 180. The degrees cancel out. And then you can cancel a 10 out in this case. And so you get 7 pi over 18. Sometimes people ask, well, what's the symbol for radians? You've got this nice degree symbol. And the answer is radians are used so often they didn't even bother with a symbol. And so if it's in radians, you just leave it alone. Early on, if you just want to make sure it's really clear, you can definitely write out the word radians, but you don't need to. All right, so you've got some homework to try in this. Hopefully it's going well. We'll definitely be able to answer questions in class at the end of the week.